So I'm recording 5 steps for a 2-column proof. The first step, we will write our given information. Was the first step of our algebraic proof to write the given equation? Yes, it was. It will be the first step. I haven't seen a proof that the first step wasn't. Tell me the given information. So then what is the given information? It is the information provided. A lot of times they will give you that. It's the given information. But sometimes they won't. So I'm going to put a parentheses out here. It can be the hypothesis of a theorem. The given information, if two lines are cut by a transversal, and the if part, the hypothesis, is the information that's not going to change. It's the information that is given to you. Most all the time, they'll give you the given information. There is a time that they don't, and you have to just take it out of the theorem. Our second step will be what we want to prove. So the approved statement. And it's literally the statement indicating what is to be proved. Statement to be proven. Generally, that's going to be your conclusion if you're doing a theorem. Maybe not. Your first 2 steps. Our third step for our proof will be a diagram. It's still geometry. We are going to draw things out. So it's a sketch. That summarizes the given information. A lot of times they will give you these first 3 steps. And all you have to do is write them down. Okay? The next 2 steps will be what goes in your columns, your 2 columns. On the left side, you will have your statements. Your statements are your specific steps that are written in the left-hand column. In the left-hand column. And last, but certainly not least, will be our reasons. Or like in our algebraic proofs, they were our justifications. So if it says provide a justification, they're saying what are the reasons that this is true. So reasons can be postulates. They can be theorems. They can simply be definitions or properties used to prove. Unless they're written in the right-hand column. I'll scroll up so you can see. your justification. And unfortunately, the best way, maybe the only way to get good at proofs, to get better at proofs, to understand proofs, is to do more proofs. Okay, so I say if I write a proof, you write a proof. It will help you just writing it down even when I write it down. Okay, trying them on your own, we'll get to that. Okay, bless you. All right, I'm going to read example 1, and they start you out very slow. They give you the given information. They give you the proof statement. They give you the diagram. They even give you these statements. The only thing in example 1 that they want you to provide are the justifications. What reasons do we need? Okay? So example 1. Fill in the justifying statements to support the proof of theorem 4.2. If there is a line and a point not on the line, then exactly one plane contains them. Okay? Somewhere early, when we talked about theorems, postulates number 1 was we accept them as true. We will never prove a postulate. Never. But we said theorems have to be proven. Here we go. We're starting it. Okay? And they're nice. They tell us we're going to prove theorem 4.2. This is it. And then they give a diagram and don't have to write all the other stuff out. So we don't have to write out the whole hypothesis. There's a line and a point not on the line. They actually draw it for us in a diagram and give me a line and a point not on the line. Okay? They tell me a given statement. What would be given for this? Line. What?
Wouldn't it be just what's on the board?
Well, yes, but the given is really the hypothesis. The hypothesis of the theorem says there is a line and a point not on the line. I could write all that out. But could I say point C is not on line AB? Does that say the same thing? There's a line and a point not on the line. Okay? Question is, do I need to write this given statement? Yes. Do I need the diagram? Yes. What do we want to prove? The conclusion. Exactly one line, one plane contains line AB and point C. Exactly one plane contains AB, line AB, and point C. So we've got the first 3 steps. We've got the given, the prove, and the diagram. What do we need next? Statements go in the left column. And my reasons will go in the right column. We're going to label it statements and reasons. And still, we're going to start with the given information first. Now, all the time, I've done it, and most of the time in their book, they will do it, where they number their statement and their reason. Because statement number 1 must have a reason for it. That way I can line up this statement, and there's its reason. Statement number 2, and there's number 2 reason. Okay? And if you can have 2 things, 2 items, sometimes there's 2 given information, I only need 1 reason for that 1 statement. Even if there's two, I just put it under number one. Alright, so what will be our first statement? The given. Can I make a note right here? Up here, when I write this given, point C is not on line AB. When I write it down here in my columns, I might abbreviate where I don't abbreviate up here. Do I have to write the same thing? Yes, you do. But I might abbreviate. So point C.
So do you want us to write point C? Or just PT?
I put a PT because I've written it up here as point. So some words I can put up there, I might abbreviate a little bit in the columns. And what is the reason for this statement? Well, that is my statement. Point C is not on line AB. It's the given information. It's always going to be the first reason. You write the given statement here, and the reason is just the given versus given. Now, this example, they were very nice and they gave you the statements. They didn't make you think too much. Okay? They didn't make you think too much. And they say exactly one plane. I will run into that line and go over it every single time. I'm sorry. Exactly one plane contains points A, B, and C. And in this one, they only want you to come up with a reason. Okay? Maybe it's a good time to get out postulates and theorems. Look through, find postulates and theorems. If you haven't used them to become handy, looking through them, now is the time we're going to go back and use them a lot. So where's the postulate or theorem of something that says, it's talking about one plane containing points A, B, and C. Maybe it doesn't exactly say A, B, and C. It sounds familiar. They are in the back of your book. Sadie thinks she has it. The question is, are you just going to let somebody else look it up for you? Okay. We're going to let her do this one. But the more active you are looking, the better off you will be with proofs. Yes, Sadie, go ahead.
Postulate 9 says a plane contains at least 3 non-collinear points.
A plane contains 3 non-collinear points. That's a great one. Yes, Abby.
Or is postulate 6 for any 3 non-collinear points?
There's this exactly one plane. Could I possibly use either one of those? Yes, I could. But we need to know 3. I will say one word that kind of makes postulate 6 a little better is the word exactly. In postulate 9, it doesn't say exactly one plane. Okay? But I would accept either one of those. In my reasons, can I simply write postulate 6? No. No, I can't, because I, as a teacher, am not going to go look up what does postulate 6 say. I don't know what it says. I gotta go look it up. I don't know what postulate 9 says. I've got to look it up. So I need you to say, what does it say? Through any 3 non-collinear points. Now, can you paraphrase? Yes. If you can get the point across to me, do it. Okay? If you want to abbreviate, there's an abbreviation for through. I don't want the OU, whatever it is. Through any 3 non-collinear points. Do I need the word non-collinear? Oh, actually, I do. 3 non-collinear points. There exists. I probably could have done without the word there. Through any 3 non-collinear points exists exactly one plane. I'm going to paraphrase, but I still need to tell, you need to tell me that you know what that postulate says. I need a good amount of it. Let's scroll just a little. And they say right now, at the third reason, exactly one plane contains line AB and point C. What did they change from this step to this step? What has changed in your statements? What did they change from step 2 to step 3? Okay, does everybody see? Up here, they talk about line A, points A and B. Down here, they're talking about line AB. What did they do? What did they change? Why can they do it? What postulate, what theorem, what definition, what property, what reason can they do that? Other than just because they felt like it. That's not a reason. Oh, Lucas has it. All right, go, read it to me.
Theorem 4-2 says, if there is one line and a point not on that line, then exactly one plane contains.
That is great. Except, what are we trying to prove? Theorem 4-2. The question is, I want to put, and I do that on purpose. You had 2 others that just fell right into my wonderful plan. Thank you. Because we're going to define a word. We're going to define the word congruent. What does congruent mean? To be congruent. Have I defined the word congruent? No, because you can't use the word in the definition. So if we're going to prove theorem 4-2, we can't use theorem 4-2 in that proof. Sorry. I didn't mean to tell you that beforehand, but I forgot. So if we're proving theorem 4-2, we can't use theorem 4-2. But there's one very close around there that's still talking about it. Riley. What about postulate 8? What does postulate 8 say? If 2 points lie in the plane, then the line containing those points lie in the plane. I like that postulate. We're going to go with postulate 8 on that one. And it says something about 2 points lie in a plane. 2 points lie in a plane. Then the line containing those points lie in that plane. I will say most of our 2-column proofs won't have that much writing in the right side. Okay, we won't have this much. If a postulate or a theorem has a name, the linear pair theorem, the vertical angles theorem, you simply write the name of it. Okay? Postulate 6, postulate 8 don't have names. Means we've got to paraphrase them. It will happen occasionally, but not all the time if we have to write it out. Okay? Let's do one more. Alright, so in this one, I'm going to give you a given statement of angle 1 is complementary. angle 3. Angle 2 is complementary to angle 3. I want you to prove to me that angle 1 is congruent to angle 2. Okay, so we've got a given, we've got the prove, and most of the time they're going to give you a diagram. This diagram to me is not always helpful. Other than to see angles that are not beside each other that could be complementary. Maybe that's a good reason for this. Now I'm going to start my statements. Long straight line. And my reasons. You might want to give yourself a little bit more room if you're at the bottom of the page. Okay. So when you are doing a proof, when a proof is assigned to you, you can always do the first 3 steps. Because the majority of the time it's given to you. You should be able to write the first statement. What is the first statement in this proof? Angle 1 is complementary. Now I'm just going to put COMP and not write out complementary again. I've already written it out once. Can I still stay in statement 1 and say angle 2 is complementary to angle 3? So I have one statement with both givens, and my reason for statement 1 is simply given. So let that take up 2 lines on my paper if I'm writing it down. Or skip a line below it. Well, see, if I wrote it here, I just abbreviated from up here. Okay, so I can abbreviate one or the other place. I'm generally going to abbreviate in my 2 columns. All right, so now, question. This is the thinking part. I talked to some teachers once about doing a proof as a hardness sometime. That's way too much effort on my part, I think. But I think it could really work. Everybody give me some reasons. What do you know? What do you know about complementary angles? Complementary do? Not supplementary? What's the difference between complementary and supplementary? Complementary is 90 degrees. Supplementary is 180 degrees. So you have to know things. You have to know some things. So what else do you know about complementary angles? I hear 90 degrees, but what specifically? They add. So if angle 1 is complementary to angle 3, could I write that down in an equation? Could I? Now I'm going to say it. I'm going to write it down and then I'm going to change it. So give yourself a little room. When we put in an equal sign and a number, is it simply angle 1 plus angle 3 equals 90 degrees? No, it's actually the measure. If we put equals, we need the measure. The measure of angle 1 plus the measure of angle 2 equals 90 degrees. Well, I wrote that for the first given statement. What about the second given statement? Can I write it for that? What can I write? measure of angle
2.
2 plus. Now, how do we know that? Oh, because they're complementary. Is it a postulate? Is it a theorem? Is it a property? Is it a definition? Abby, what does 6-1 say? Yes, but I didn't read the beginning of this. We're trying to prove that here. We are trying to prove here in 6-1. I'm sorry. It was said in the instructions beforehand. I never told you that. You would see. No. I read there in 4-2. I did not read there in 6-1. I know. Do they have to be postulates and theorems? Could we just say, you know, all those little blue words? All those little blue words that I make you write down and you know? Because we're really just trying to prove this. Why could we do this? Is it just simply the definition of what? Complementary angles. The definition of complementary angles says the sum of two angles equals 90. The sum of two complementary angles equals 90. All we did was say, hey, they're complementary, so I can write an equation. No, it's the definition of complementary angles. I could say it's the definition of, I don't know, there's lots of definitions. Or properties. A reflexive property. You don't have to write out what it is. You just tell me if it's got a name. Now, a while back, maybe last week or something, we talked about y equals an equation. And you had another one that said y equals another equation. What could we do if we have two things equal to y? We could set them equal to each other. Does everybody see up here something that equals the same things? Do we have two equations that equal the same thing? We do. What could we do with those two equations? Can we set them equal to each other? Yeah. So if I say the measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 3. Why can I do that? Well, angle addition postulate says this piece plus this piece equals the total.
Wait, it's not actually.
I would take substitution any day of the week. Somebody else told me, well, you know, if A equals B and B equals C, then A equals C. Somebody told me the transitive property. That works also. I would accept either one. I tend to think of substitution first. If I have y equals, then whatever that is, I can plug it in for y anywhere I want. Okay? Now we just have an equation. And if we have something on one side of the equation and something on the other side, 5x and a 2x, what could I do with those x's that are on two sides of the equation? Could we put them together? How would we do that? We would subtract one from the other side. So does everybody see something that's on both sides of the equation? The measure of angle 3. So in this step, can I simply subtract the measure of angle 3 from both sides? What step is that? What did we just do? Subtraction. And after we subtract, what do we always do? Simplify. So after the subtraction, what are we left with on the left? The measure of angle 1 equals the measure of angle 2, because those have canceled. Is this what we wanted to prove? Do we feel like we're very close? but it's not quite exact. Oh, but what's different between them? The little m's and the equal sign up there, I want congruent. What do you know about equal angles? Angles that have the same measure. If they have the same measure, they have to be congruent. Why do we know that? Definition of congruent angles. We do not have homework. You are not ready for this on your own, I promise.
Wait, we're not seeing.
Okay, I was like, oh good.
But we will do some more tomorrow. You need to do more.
Towards the end, I